So good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and RackN. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but first I have a couple of housekeeping notes to cover. First, today's session is being recorded, so if you miss any of our discussion, you can rewatch it shortly after we conclude the webinar. You'll receive an email with a link to access that on demand. We do have a Q&A tab on the right side of your screen, and that's where we want you to send in any questions that you have for Rob today. And for any other conversation you want to have with the rest of your audience members, you'll also find that chat tab on the right side of the screen. We have a couple of polls throughout today's presentation, so we really appreciate your feedback on those. And if you would like to download today's slide deck to help follow along with the webinar, that is available by clicking the Handouts tab. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is scaling IaC, Terraform, Ansible, and GitOps with infrastructure pipelines. And I'm joined today by Rob Hirschfeld, CEO at RackN.com. Rob, thank you so much for taking the time to be with me today. I'll give you the floor.
Hey, Cody, thanks. I appreciate you joining us. And I'm excited to be here on St. Patty's Day, which is sort of fun. I've got my green shirt right here for everybody. It's not going to work very well today, but it's always fun to have a good St. Patty's Day webinar to go to. And we're going to spend some time really bringing you all up to speed on infrastructure as code and thinking through the next generation. We've spent a lot of time as an IT industry and as a community doing automation and now happily talking about it as infrastructure as code. And what we're finding when we talk to customers is that they are struggling to scale their infrastructure as code efforts, really going from doing this, one by one or team by team, and treating automation more like a software product, which is how I like to think of infrastructure as code. And we'll talk about a lot of these things as we go forward. What I want to start with a little bit is just to give you some of my bona fides and credentials. My name is Rob Hirschfeld. I'm CEO and co-founder of RackN. And I personally have been doing infrastructure automation for over 20 years, from the very earliest days of cloud, data center, and infrastructure. And we started RackN 7 years ago because we were very focused on helping companies enable data center autonomy. We really saw that while the hyperscalers were beginning to be very good at doing that, we felt that everybody could be able to run their own infrastructure. And even if you're in the cloud, you're still running that infrastructure to a large extent. And so your ability to do that is really important. And we think everybody can do it. We know everybody can do it. And that's because we've brought this unique perspective in helping make infrastructure agnostic, multi-cloud, hybrid, at bare metal, using whichever vendors you want. And we do that as a software company. And this is really important. RackN isn't a services company. We're not providing data centers or infrastructure. We are really helping companies do the work themselves, take control back from those providers so that you're always in control. And that gives us a very unique perspective to talk about treating automation as a software product, which is where scaling infrastructure as code is. When you think about how you want to build your automation and your infrastructure, you want to have the same degree of predictability that you would have out of a software deliverable in your automation and out of your infrastructure. And so that really gives us 5 key areas that we're going to dive into today around how we scale infrastructure as code. And this is really the topic today. So I'm going to save going into each one of them in the detail for the body of the topics. And excitingly, we're going to have demos for each one of these topics to actually show how they get implemented, not just as concepts, but how they can show up in your own infrastructure. Whether you're a RackN customer or investigating RackN or completely committed to doing this all internally and on your own, you will learn how these techniques can be applied into a generic set of situations. So these are general principles that we help customers implement and we see being used across the industry. And then you'll see the RackN specific implementations too, of course. So before we dive deeper, what I want to do is stop and let you, give some information back about how you're doing this type of work. A lot of times we see a team being formed inside of companies struggling with infrastructure as code and automation, where they're trying to create some consolidation around this, what they'll call a platform engineering team in the sense of an IT platform. So they're trying to have a way to make infrastructure and automation work across the organization rather than a team by team effort. And people are in a broad spectrum of this case. So sometimes it's a tops down initiative where the CIO is saying, we got to be better at working together. Sometimes it's coming from the bottoms up where companies are doing DevOps or site reliability engineering work. And they're really saying, we want our teams to use the same automation or be able to collaborate. It could be a security driven implementation. And we have also seen companies that are just trying to say, we're going to do whatever we need to get done to make all this stuff work. And so it's a pretty big variation across the board on how those systems get going. And if you've never heard the term platform engineering, that's fine too. You might have a different name for it. This might be your DevOps or site reliability um, initiative, or you might just not be there in the journey. If you're not there in the journey yet, it's something to consider. If you have multiple teams, each rowing on their own doing this, it's very hard to find control back. So Cody, do we have our slide results? And it looks like what we're seeing here is it is a tops down initiative. And that makes a lot of sense to me. It is something that we're seeing where individual companies are saying, we can't keep having the wild west of automation in our infrastructure tooling and setups. Excellent. All right, Cody, thank you. And this is consistent with what we see where the CIOs and the executives and companies want their operations to look more like their development efforts. This is that productization concept, really saying we need more control, consistency, we need collaboration, we need security and audit, right? These are really core things that businesses need that development teams have gotten pretty good at. And with infrastructure as code, we're starting to see that emerging as well. And that's an exciting part of the journey. And I want to stress here, this isn't about individual tools. The tools that we're using are great. The people that we're interacting with around infrastructure as code are really smart, well-meaning. They understand their infrastructure, but they're still struggling. And it's not a vendor's problem. We have really good vendors, whether on the hardware side or in the cloud and virtualization platforms. The challenge is that everybody's doing their own thing and not focused on how we work together. I like to explain it this way. If I was building a house and I had a team of electricians in the bedrooms doing US plugs and doing everything to that standard, and I had a team working in the living areas doing European standards, and then I had another team showing up in the kitchen and just wiring things together and making it up as they go with wire nuts and connecting everything together. That's how it feels today with infrastructure as code and automation. Every team is doing their own things. The standards are all over the place. And that means that when we build the house and put the drywall up, we don't know what's there. You get a log4j challenge coming through and you don't know which wiring is going to catch on fire and which isn't. And we can't keep doing that. We have to have people able to collaborate and work to repeatable standards and work together, because that's really how building standards emerge. That's why they keep us safe and they allow us to build more effectively. And if you think, this doesn't impact me because I've got my silo, I've got my team, and they're doing a really good job. What we find is that even within a team, even within a pipeline of work, what we would call an infrastructure pipeline, there are still challenges that the tools that people are using aren't handing off, even within one work stream, adequately to really build an end-to-end process. And so you might find that even if it's just one team and you're not worried about a platform engineering effort across your organization, there's a lot of improvement you can have just working linearly within your own control. And that's what we do with RackN. Digital Rebar is our product. It's a software package that doesn't replace or eliminate Terraform or Ansible or cloud or virtualization platform. It takes it up a level to connect connect those things together. It actually builds that infrastructure pipeline so that you can coordinate the work start to finish all the way through. And then it does it with infrastructure as code. So that decomposition is modular, which is exactly what we're going to show today, and allows teams to collaborate and work together. Because fundamentally, this isn't a problem that one person or one team is going to solve. Just like a CI/CD pipeline, the opportunity here is to help people work together. Digital Rebar, and there's some videos and training, and I encourage you to visit our website to learn more about the tech here. We're going to show you this product a bit. This slide is a high-level architecture, just sort of showing you the basics with an API-driven system with workflow engines behind the scenes, agents that can run both on the server or on the machines that we're managing and move back and forth, all around an infrastructure as code system. And then one of the things that's very distinctive with Digital Rebar is it is completely infrastructure agnostic. So able to handle virtual, physical, cloud, edge environments, all with the same basic control elements. So really unprecedented from that perspective. And it's also software. So unlike most anything else in the market, this is something that our customers run themselves, and you maintain the secrets, you maintain your own security, your own control panel. We never get our customers' information, and that's the way our customers prefer to have it. The other thing that's really worth stressing here as we go into the demos and show you how things work, and this is core to scaling infrastructure as code in general, is we write our software, and I hope you do the same thing, with reuse and modularity in mind. So the idea that you would have an code that is only used by you or only used by one team is antithetical to what we try to design. So the whole purpose of infrastructure as code is to create this modularity and reuse that we see in a development platform. So our code is in use by every customer. We don't have bespoke customer sites or automation packages. It's used on-prem, edge, and cloud with the same automation components, and day zero, day one, and day n. So we're actually able to have this high degree of reuse and modularity across all of our customer base, which means when we improve something in one module, all of our customers can get the benefit of that module. When we add a new feature, all of our customers can get that new feature. It takes you out of the consulting or team by team approach and starts allowing you to get economies of scale way outside of your one organization, your one team. And that's a really important thing for eliminating toil inside of infrastructures. And this is something we've been helping customers do for years. We have significant scale deployments, over 20,000 machines being deployed and exercised by different customers. We have multiple customers operating at this type of global scale with incredibly high footprints, doing very fast turn CI/CD infrastructures, doing global deployments, really changing the time it takes, the way people think about doing automation. Because once you have a reliable automation process, you can deliver infrastructure at a completely different scale and pace. You actually think about how those things get delivered totally differently. Now, we also have very small customers. We have people as small as 20 or 30 systems that are being automated, and you get value out of an end-to-end automation chain really on day one. It's a remarkable transformation in how you can actually build and manage infrastructure and then confidently scale it across different teams and across different organizations. So that brings us to thinking about infrastructure as code at enterprise scale. And we're going to go through literally 5 different demos illustrating each one of these points for how we take infrastructure as code at scale. Everything from building infrastructure as pipelines, cluster operations using Terraform, Ansible in day 2, and then GitOps integration. But before we do that, I do want to stop for a poll a little bit, get you thinking about this type of interaction. And we see this quite a bit. While we're talking about infrastructure as code that could reach into incredibly broad depths, everything from integrating into an Active Directory system or a ServiceNow catalog, get tickets, talk to Slack, all those things are important. But we find that customers all over are really struggling with these 2 products, Terraform and Ansible specifically. They both have near universal adoption, but they're not integrated. And so a lot of what we've seen happen for a good infrastructure team is they have worked to put these two products together. And they'll do the provisioning piece, that's the Terraform piece, and the configuration piece as components. Now, some companies don't use these two products. They might do it with Pulumi and Puppet, or Chef, or Cloud Init, or Bash scripts to wire everything together, the CLIs or Cloud Formations. But what we see is universally every company that's dealing with infrastructure is challenged by this exact paradigm shift. I have something that does provisioning and something that uses Ansible. And so you're really faced with this simple decision. You either have to find a platform that puts those two things together for you, because everybody has to do them. You have to build a platform that does it. And we see a lot of companies who've invested time and effort to try to control this and now have a bespoke internal tool that they have to maintain to run it. They might have done it a whole bunch of different ways. And this is the most common thing that we've seen in practice. It'll be interesting to see our poll results. And then we have a couple of people who really don't even think about this yet, that their journey in infrastructure as code is still, I set things up and then I move things other. And yeah, the poll bears this out exactly. And this to me is part of the challenge that we're talking about scaling infrastructure as code. Because when we look at doing something as essential as provisioning and configuration together, but different teams doing it different ways, means that you can't have teams collaborate. And so, Cody, if you could, well, let's keep moving on. Thank you. When we look at this, the challenge of doing these a whole bunch of different ways means that we're literally going to be struggling on every one of these dimensions. We're going to lose the benefit of learning, sharing, and most importantly, collaboration and improvement across. And we'll walk through each one of these things. What we want to start with here is on the GitOps side, and I put GitOps in quotes here. GitOps is still an emerging term, and it means different things to different people. We're talking about GitOps outside of the Kubernetes realm. And so when we talk to people about what they mean by GitOps, what they really want is they want automation that is controlled from source. So that means that things should happen when things happen in your Git repositories, but it should also mean version control and immutability. And I really want to stress that before we get into the demo, because I'm going to show you how you can connect things from Git into your infrastructure. And it's very exciting, and it really does help companies scale to have that type of integrated process. But there's a lot to be said here in something as simple as versioning components of your automation so that you know what's delivered at each site. And it's something we spend a lot of time doing as we build infrastructure as code into our system in immutable ways. We also then make sure that we can track what's been deployed and what's been versioned, and make sure that it's not changed in the field, that it's only changed in the development environment. So let me show you how this works from this perspective. And in this first demo, I need to give you a little bit of background first. What I have on screen is RackN's product, Digital Rebar, and I'm showing it to you at the clusters view. The primary view that people will use when they're running an infrastructure is this machines view. This shows all of the machines that we've provisioned in the system. I've already provisioned a distributed infrastructure, which we'll get to as our next point. But in the meantime, what I want to do is spin up a new cluster for us. And I can do that as simply as bringing up a new cluster. We're going to call this demo 1. And for this case, I'm going to choose to do a very simple cluster using our internal context. So for the interest of speed, I'm going to go ahead and just build a quick system. I'm going to do it based on a infrastructure pipeline that I've already defined. You'll see Zehicle a lot in here. Zehicle is my Twitter handle. So if you want to ping me or interact with me outside of this, Zehicle is usually the one easy way to find me for everything. And that's what I'm using for a lot of these demo handles. So the pipeline that I'm going to use is a Zehicle cluster pipeline, and that's designed for this demo. And it literally builds all of the infrastructure and automation pieces together to deliver clusters and then the infrastructure for those clusters behind the scenes. And so I'm going to let that go. We're going to use our context broker, which is our internal container-based infrastructure. And I'm going to use a lab icon for this to make it very easy to see. Give it a nice attractive color. And by setting the icon, it's going to make it easier for you to identify which cluster we've built this time. I'm going to go ahead and say go. And this has now started the process of building that cluster. So we talked about an infrastructure pipeline. An infrastructure pipeline is a sequence of workflows that are operated together. In this case, the cluster has its own lifecycle, something very distinctive in Digital Rebar. Clusters have their own way to do automation, and I can actually track exactly what's happening. We'll dive into this more when we talk about the observability component of infrastructure as code, but I can literally watch all of the instructions operate to build that lifecycle. Now, as the cluster gets built, what we're actually doing here is the cluster is starting machines in the system. And so we're just about the phase where we're going to initiate those machines and they're going to get built, and then they will start their own infrastructure pipeline. So part of what Digital Rebar does here is it will build the systems, and then it will start a pipeline for those machines. So each machine has its own distinct pipeline also. So the cluster has a life cycle and the machines have life cycles. And you can actually see them coming up here. So they got added, we detected that. And then within each one of these machines, I can go and look at the activity as it gets built and begins doing the work. And that's the basics of the Digital Rebar operation. Now, you'll notice I'm just, for speed, I'm just using the internal containers here. If I wanted to, we have resource brokers that can be defined. And this is our one of our demos also, where you can actually define new brokers that interact with different cloud resources or physical resources also. So it's very flexible from that perspective. If I'd asked for a cluster in Amazon, it would be building my machines in Amazon or Linode or Google or Azure or Oracle, really wherever you need to have your systems. And we'll explain how that works. So now that I've shown you sort of this very high level, this is how Digital Rebar builds a cluster, what I need to explain is that the pipeline that I use to build that cluster is one that is not written in Digital Rebar itself. If I was to come in and drill down on this cluster here, what you'll notice is that it's in a read-only mode. So inside of this system, I don't actually get to edit this cluster description at all. All of the components, everything here is actually defined for me inside of a Git repository. Let me pull that up for you so you can see what we mean. And this to us is the core thing of what makes this infrastructure as code. When we're defining our automation, we don't set it up in the endpoint, in Digital Rebar endpoint. We actually define it in source code control managed systems, and then we can version it and propagate it. That comes on in this. This is a specialized repository that has the content for this demo in it. And when I go into that content, I can see profiles and templates that I'm using to actually run the demo. The meta actually contains the version and background of the content that gets all bundled together. Digital Rebar does this because when you build up infrastructure as code components, you want to be able to decompose them into smaller units and then treat all of the pieces of that as a portable, immutable set. And that allows you to fix a variable, update things, and then know exactly what was delivered. And we're going to go through some of those pieces. The profile that I was showing you is this application vehicle cluster. And in here, you'll notice that this is where I've defined that cluster. And if I want to make this cluster bigger, I can go ahead and edit. And I can add in a couple of machines into the cluster. That'd be nice. Name them what I want. And go ahead and commit that change. And because this is infrastructure as code, and now I'm violating good. Normally you'd have a pull request and a check and all sorts of balances for the demo. I'm just going to go ahead and commit to main and make things go. But what you want to happen and what will happen here is that when I do this commit, it actually has a webhook that's going to tell Digital Rebar there's a new content pack. That content pack is going to get rebuilt. So that profile is going to change, still locked in Digital Rebar. It's going to get pushed in. And then from there, I'll show you how these things work. From there, it's going to spark this trigger. So we have a trigger here that is going to go ahead and get that webhook. It's going to take that updated content. It's going to build that new content pack, upload it as read-only content in this endpoint. And you can imagine if I had 50 endpoints, I could have them all doing this. We also have a way to distribute this content through Digital Rebar alone. And then I have a secondary event trigger that says when my content has changed, I want you to reevaluate all the clusters. So there's actually a webhook that triggers on this, but if content showed up from any source, it would automatically reevaluate my clusters. And what's happened here is behind the scenes, it's already gone through and it's reevaluating these clusters. And now you can see I've already created these new machines and they're starting to come up and they're going through automatically. If I'd eliminated machines, you would see the same type of action. It would do the destruction. If this was in the cloud, it would be deleting the machines, actually pulling them out of the system. Because we're using a cluster, the cluster can make actions to gracefully remove a machine before it does that delete operation, or when a machine gets added, it can automatically add it back into the cluster. So separating the workflow for the cluster from the workflow from the machines gives us a lot of control hooks to actually do real infrastructure as code automation at the cluster level, which is, you'll notice that's where I was taking my actions. So a lot of bits and pieces all coming together for that. If you're thinking about how these are audited and observed, all of this work is actually done, and we're going to show this in the observability, is actually created through work orders. So everything I'm showing you is not done as just an API request that then magic happens. It actually creates a work order, which is auditable and trackable in our system, and we can see how those components all fit together. So that's what's going on behind the scenes to make these systems connect together. And you can see the job log is actually coming through and showing me exactly what's going on. And I can go back and check and see everything that's happened in the system. Whew. All right, that's a lot in the first demo. And it's important to sort of build up all the pieces of what's going on. And this is where we started from with Digital Rebar. This idea of building from source, version control, and immutability has been really important from the start. And we have a question here, which I'll take before we move on, is so Digital Rebar has both models. It has an eventing system behind the scenes, so it's very good at doing push information and taking actions based on events. And you can also do pulls where you can set up a trigger and pull data in from a source as you build a workflow. So we're very flexible from those models. I will show you the TF state. We're going to hold that question a little bit. And when we get a little further down the road, that's a great question. So we'll talk about that. Let me move into the next. Sorry, and I had a graphic I didn't show you all. This is the workflow that I just showed you, where we have the infrastructure as code content, the trigger by webhook, and then moving through the process to build and expand the cluster. Now, that's all important. Everything we're going to show you is important in its own. Connecting it together is how we scale. And one of the things that's really important here is thinking through how we have multiple teams and multiple sites collaborating, right? We don't run 10, 20,000 system infrastructures with our customers by having a big single site. What we actually encourage them to do is have distributed sites with local control, which improves the resiliency of the system. And I'm going to show you a little bit about how that works using some of the same constructs for cluster building that we've done before. In the first part of this demo, I'm going to show you how we work with a multiple site system, and then the Digital Rebar system manager actually shows me those operations. And then I'm going to show you, and I'm going to jump over into a second component, do the same operations, but from the manager, so you can see how we would use these operations from either side of the system. So with that, what we've done here, and I've shown you these machines. So we have a couple of different Digital Rebar sites already running. Those get registered as endpoints, and I actually have those connected in. And what I'm going to do here is, instead of doing things from the manager for this time, I'm going to jump over to one of my sites. I'll pick the central one here. You can see I just logged straight in. This is a new digital rebar site. So I'm showing you machines so that you can realize there are no machines defined here. It's a completely independent site. So imagine this would be a new region or a new data center. It's important to think of this also as potentially another team. And we did a Cloud Field Day demo that really highlighted this concept. Because of the way we've done the distributed control, instead of having a big centralized system, you can easily have teams that each have their own digital rebar site, do development, test, and prod with their own work, share infrastructure as code components, get support from a centralized authority, but don't have to fight for, oh, wait a second, I need access to the big server in the sky or the big control system in the sky. You can actually decentralize that on a team basis as well as by a geography basis or a cloud basis. So in this case, I'm going to do exactly the same operations that I had before. This is my central site, so I'm just going to call it Central 1. And we're going to do, this time, I'm just going to do a simple base cluster. I'm going to do the same context broker. You'll notice I haven't set up all the cloud brokers here, so there's only the context brokers installed. And I'll just leave it to default 3. I will go ahead and set the pipeline here. Let's use let's see. We'll do the home. This will be perfect. Nice pink icons here. We'll use the home icon. That'll help distinguish it. When I hit save, we're going to go through the exact same operations that you saw here. This is a pretty routine system. This one's actually even faster than my manager is. And so it's already building those systems. If I come back over to here, whoops. Okay. If I come back over here, we're waiting for the cluster at this point to join. You can see those machines are coming in. This is exactly what you expect. This is just another digital rebar system. The thing that's exciting is if I come over to the manager, what you will see happening is exactly the same process here being mirrored for those machines. So here's my central systems. If I jump over to here, I can actually see the activity. It's already done. Those actions are being done for me, and I'm watching them happen between the two systems. So anything that's happening on that edge site, I'm seeing happen at the same time at the manager, and I can actually see live views of those operations and actions occur. So the managers are able to see and observe and potentially help with the people running the edges, but the edges aren't encumbered by having the managers having to fight with the managers or see all of the resources in the manager. Some people ask about multi-tenancy or role-based authentication, which we support. But in some cases, it's simpler to just give somebody their own control plane and allow them to work without having to worry about commingling resources at all. And then what's fun is I can come back, and if I want to create another central site, I can go and say, I'm going to build a second central site. And here I can target which endpoint I want to use. So when I make this call here, I'm going to build my central site. Here's my context broker. We will give this a green, we'll use the same icons, different colors. And when I say go here, what the manager is actually doing is it's going to that edge site and is doing the work to the edge and then pulling back the mirror. So I can already see the systems are going to be created over here from that system. So here's my central 2 already going through. It's being created on the edge site, and I'm going to get live updates of the system as it's built. And if I jump back over into that other site, what you would see here is those machines have been created and run in the system. So the manager has the ability to take actions against the sites that it's managing, and you will have full visibility in both components. All right, so let me pause, look at questions. Oh, and there's one other thing I want to show you before I'm going to clean up a little bit. From here, let's jump back to the manager. And because of the way the cluster operations work, I'm able to do a cleanup operation. So when I do a cleanup operation here, I have to be in my workflow mode to do that cleanup. It's going to go ahead and pull not just the cluster, but it's going to do a structured remove of those machines from the system for me. If this was doing Terraform, it would look up the TF state file and then actually pull those in and remove the machines from Terraform. So I have a very easy cleanup process. As a matter of fact, one of my triggers in this environment is a nightly cleanup, and it just removes, it's in a dev environment, it just removes all of the clusters every night so I don't rack up my cloud bills because I forgot to turn things off. All right, let's jump over to slides and look at our question. We're going to show playbooks in just a moment. Yeah, you can definitely add playbooks into the system from Git or from internal templates, and then use that to manage and switch the versions. The whole intent here is to have that type of fast and easy control with very immutable types of infrastructure. So the purpose here is to make it easy to set up and destroy clusters. One of the things that I really like about the way we've decomposed control between clusters and machines is that for a development team, you might not care about the machines at all. You might just want to work in the clusters. And this is actually exactly the point with repeatability. So and I think I'm going to answer this question in this next demo a bit, showing you some of the repeatability pieces on how these systems work. So the idea here is when we're building these clusters and infrastructure pipelines, we're doing it in ways that are very easy to decompose and add steps or pull steps apart. And that abstraction allows me to focus at the right level. A lot of times the development team, this is where Terraform builds clusters of machines. You don't want to have to work machine by machine if you're used to using Terraform. You want to work at the cluster level. That's exactly what we're doing. The nice thing here is that because we have a lifecycle for the cluster, you can then add in steps that you want performed at the cluster level as part of that process. And the system has the ability to wait or not wait as cluster pieces are built. For this next slide, though, I want to show you a different aspect of this, which is the day 2 operations component. So we've seen systems that do day 1 quite a bit. Day 0 for us means pre-populating. So before you even have systems that show up, you can predefine a whole bunch of information, and then that's your sort of day 0. Day 1 is the actual provisioning. Day N is this idea that I want to take that same automation I built, those Ansible playbooks or scripts or things like that I need to run, and run them in the system, which is what work order mode does. And it's worth taking a moment and explaining work order mode. The way Digital Rebar is built, the systems have 2 operational modes. They have a workflow mode where they run a long sequence of tasks, and they have a work order mode where they take the same tasks, the same underlying components, and can then issue them as jobs. And those jobs could be triggered by an external source, run on a timer. They can be done ad hoc strictly through the API. Or they can be done by events happening within Digital Rebar itself. And I want to show you one of those. I've built a blueprint for this demo called Vehicle Test. And what it does is it runs Ansible playbooks locally. So its job is strictly to run an operation to call Ansible playbooks. Now, Ansible playbooks local means it's going to run, it's not doing SSH. We have an Ansible remote. You can do SSH and run Ansible playbooks like a tower would let you do. In this case, I just want to run a simple test script here. I'm going to define that test script right here. So this is something there. I've added a template. I'm going to jump over to our IDE. You'll see in our templates directory, this is part of our infrastructure as code story. So it's an Ansible template. It does nothing but do some debug statements and collect some data. So pretty innocuous one. But what I've been able to do here is I've defined a blueprint that calls a template. And this is defined as a variable inside of Digital Rebar and easy to override. So you can build a work order without a blueprint where you pass in the information, or you can predefine things like I've done where you always want to use that same playbook. And This is actually included by default in the workflows that built those machines. So those machines have already run this playbook as part of their process, but I have a reason I want to reassert it. I want to make it happen again. So here I can take the blueprint and I can identify machines that are in work order mode. Once again, if they're in workflow mode, they're going to do full workflows, infrastructure pipelines, or if they're in work order mode, they can do these event-driven tasks. And it's actually been very important design-wise to have you choose which mode you're in. It keeps you from accidentally destroying or creating infrastructure when that wasn't your intent. And I can come back and choose these systems. If I go ahead and run that blueprint, what you'll notice is it's actually running them all in parallel. Each blueprint, I clicked on one of them. This is all the blueprints that are running for that system. This is the first one I've done. I can click down and see the activity of that running blueprint. So I've just drilled down through. So I went from my blueprint, I went to the machines that were running that blueprint, and now I'm actually executing that blueprint and seeing the results of it coming in the system. And you'll notice this is the Ansible output from that action logged into our jobs. So when I look at that, what that means, you can see these are the blueprints that I just spawned. They all happen in parallel, and they're allowed to run the system in a parallel operation. What's really gets exciting here is that from the manager, I could actually spark the blueprints to work across my fleet. So if I had a security vulnerability or scan that I needed to run, I could set that up to happen across the fleet. The people at the edge sites would see that action and see that happening, but the manager would be able to get this consolidated view of the infrastructure that's really, really important, while on the other side of that, the edges would be able to do their own work. And part of that means, this is why the infrastructure as code piece is so important. That only works because we can actually distribute automation across all of these systems in a versioned way and have different sites at different version revs of the system. So there's a lot of thought that goes into how these pieces are actually get built together. So thank you for the compliment. I appreciate that in the questions. Cool. This to us is really nice. And I want to reinforce one thing. I'm showing you this with Ansible because people do a lot of Ansible, but we are tool agnostic. So the goal here is not to, make people use Ansible or make people use Terraform. What we're actually doing here is making it possible to connect those pieces together. And so when people have tools that they need to run, if it can be as simple as running a script to make it go, or if you can run it in a container, we can automate a container as part of a workflow. And there's a lot going there. Let me keep moving through some of these demos and make sure we get you done in time. The next piece of this demo, and the next thing that's really important from a scaling infrastructure as code perspective, is now that I've gotten version control, I've gotten distributed teams working together, I've gotten repeatable units that I can build into consistent results. That's all critical, but it's not helpful if you can't actually observe it. And one of the things that we've seen that is really critical to making any operational platform work at scale, and the at scale is really significant, is that you have to have a high degree of visibility and transparency in how those systems actually get built and how they have compliance in following the rules. And what you'll see, I'm going to dive into two things for you. One is I want to show you what an infrastructure pipeline looks like from that perspective. We have a lot of them in the system. Let's see. Actually, I'm going to show you on the workflow mode. It's a little bit easier to see. All of the universal pipelines start with the word infrastructure pipelines start with the word universal. But if you were to look at, say, one of these ESXi, thank you, Cody. If you were to look at the ESXi workflows here, what you'll notice is they perform some standard pieces, then they drive through a whole bunch of ESXi steps that you may not care about. um, and this would be general of any type of system we build. But even if you don't worry about those things, from a compliance perspective, we're passing through those steps. So if you want to then turn up your testing from a production perspective, all of them are in the workflows. So part of what we're working to achieve here is a very consistent, repeatable approach through the system. And that means that the dev, test, and prod infrastructure pipelines can be very similar, even if the infrastructures that they're supported on are different, and the system's designed to accommodate that. But what I want to show you here, and I'm going to go ahead and build a cloud infrastructure as part of this demo. I'm going to go ahead and build one in Linode. We'll start with Amazon, where I'm going to choose just a standard cluster base, and I'm going to choose, click on the right thing next time. I'm going to choose an AWS resource here. Here's my AWS broker. I'll bring up 3 machines. I can use Amazon's logo, so it'll be easy to distinguish, and start running that. Now, my point here is not to show you the multi-cloud piece, but it's actually to focus in on what's happening behind the scenes with the transaction logging. So what's going on now is I've started a cluster level pipeline that is building my cloud resources. And you'll see that every step of this, it's working through this broader workflow, and it's then going through and building the systems as it goes. And these are all pretty fast tasks. When we get to some that are a little bit slower, like the Terraform step, what you'll see is we get live results back of that task running when it's operating. And this is true whether it's running on the machine remotely or it's running on the DRP server. That live feedback is absolutely critical. So I can watch my Ansible runs run and get second by second updates, even though it might be a long running process, whether it's running on the server or running on the machines themselves. And the same is true for Terraform actions or any long running action. Pretty much the only thing we don't get to see inside of is a boot process, because it's just it's systems booting. We don't have a lot of visibility, but we work really hard to ensure that this type of transparency is integral in the system. So you'll see I've actually gotten to the point where we're doing the cluster provision. Cluster provision is not done by the cluster. It's actually called out to a broker. The broker abstraction here is really important because it actually allows your cloud teams to then manage and watch how these processes are working and have their own control. So every part of this is logged against the broker. And a broker could be a region, it could have a key, you could have a centralized broker. But if you have different teams with different cloud privileges, this is exactly the place where you would be able to say, one team gets this and another team gets a different one, and have that protection. Now, it's always worth noting, we do support external secrets. So you don't have to put all of the critical information like credentials into Digital Rebar. If you have a secret store, which I hope you do, we'll integrate with those. Digital Rebar, of course, has its own encrypted secret store also. But you'll notice here, as Terraform is running, we're getting live updates back for the system. Somebody had asked earlier where the state file is going to be stored. It's worth noting, I'll pause for a second since this is a slow process. Every time I run the cluster, the broker is smart enough to know that it has to store the state file. And so it's going to show up, hasn't gotten there yet. It'll pop in live in a minute. It'll actually put the state into the cluster that's running. So if I have multiple clusters, each one has its state file, and it's managed here exactly in process. I'll talk about licensing in a little bit. There you go. So now my state file just showed up. So here's my broker, Terraform info. There's my lock files and things like that. So we're very careful about how we manage that. One of the things that Digital Rebar does in this cluster model that really is handy is that when that Terraform process runs, we actually detect the machines are created or destroyed, and we'll take matching actions in digital rebar. So you'll notice here that the machines, even before Amazon's finished creating them, we have already come through, created them in digital rebar, and they're waiting for that cloud initialization. So they have a pipeline ready to go. And as soon as the machines start, which you can see them starting right now, they're going to go through that pipeline and you're going to get to watch it happen. So from an audit and a drift detection perspective, we're actually able to know that machines were created and then go back through and have those systems work. And you're actually watching that process live. And what I want to point out here, because we're talking about observability and traceability, is it's great to be able to see the systems built and created. So there's no hidden machines in your Terraform plans. Terraform plans are also in a easy to find location. But as the work is being done, we're actually building all these job logs. And those can be audited and checked. If somebody had a problem, I can go back to a job log. System's been running very clean, so there's nothing that's failed. If something had failed, I could actually go back to a log and see exactly what had happened, what data was collected, what the error was, and help troubleshoot the problems. And this is critical as we scale, because you might be running a process where you need help and it's broken and you don't know why it's wrong. Because of the way the system's built, you can go back through and have somebody else pull up a job, see the log, see what parameters went into it, recreate the situation. That type of auditing, logging, and transparency is absolutely critical to scaling, because it takes you out of I have to walk over to somebody's shoulder or jump into a Zoom session to see what went wrong, to let me diagnose the problem, stay in my expertise, see exactly what the code was, and have all of that information available to the operators in the system, right? It's also important from an audit perspective. The same is true, by the way, for work orders. So when systems are run, work orders also generate jobs. And so you can see the system running in the background and see what's actively live in the system and track all of that information. So we work on a high, we're operators. You want to see what's going on in the system. You want to be able to always know and check out what's active and running. Very, very important. And that brings us, I keep forgetting to show you the backing slides. Cody had said that you can download these slides and check them out. I highly recommend that. These little flow charts will help you sort of back into the type of work that the system is doing behind the scenes, because there's a lot going on. And I'm going to, for collaboration, I do actually have a demo scheduled, but in the interest of time, I'm going to try and be sort of brief, because I've been talking about collaboration the whole way through. And one of the things that I think is so important and often overlooked is that the thing about scaling infrastructure as code is the collaboration aspect. It's being able to start with something like digital rebar, and we know that you will need to have your own Terraform plans or your own Ansible scripts, but the starting point of having all the pieces and parts already there and working together means that you can reuse things that we already have going. And the system is designed that you can keep getting the benefit of that. And also you can share with other teams. You can work with other people. So if somebody has a really good Terraform script, and this is exactly where the demo for collaboration goes, somebody has a really good Terraform system, what you want to be able to do is add in and reuse Terraform or Ansible or Bash script or whatever pieces and parts you're using. The way we decompose that work allows that type of collaboration to happen. And I will show you this sort of at a very high level. If I was going into my resource brokers and adding a new resource broker, so if I wanted to add a new, say, Linode Cloud resource broker, it's already one there, so I have to call this, I'll call it demo broker. What I'm going to start with from this case is there's a whole bunch of information already known. I'd need a security token. I'm not going to add that. Just going through to try and show you how we build these things. But when we build Terraform, it's based on a resource set. Where'd it go? Oh, I called it. I'll show you what it's based on, but it's not picking picking the right one. So we've already defined the components that are necessary to stitch all these pieces together. And this is where, and we have full demos for this, and I encourage you to look. We just published a blog post. This is why I'm sort of moving quickly here. But instead of building a single plan, the plan is actually decomposed into parts. And so if I wanted to, I could build my own version of this or override this and add in a firewall script or change my Amazon security zone or any type of Terraform. Is designed so that you can pull those pieces apart and then stitch them back together. There's other people are doing this quite a bit. We've really put a lot of thought and we have a lot of resources to make this a very scalable process in how we do it. And that means that I can take a broker like I was trying to build and run that broker. So I could have created a demo broker or here that actually has different characteristics but is using 85 or 90% of the same code. And that is part of what makes collaboration work. Collaboration is people working together, but you have to have tools that encourage and enable reuse across your organization. Whew. So I'm going to jump out of demo land and try and leave a couple of moments for questions in the process here. The simple one is licensing. It is by the host. So we differentiate between virtual hosts and physical hosts. So there is a license per virtual machine that you would have. It's the maximum number of virtual machines. So we don't track, like if you create and destroy a lot of them, which we see people doing, then you would pay for the maximum capacity of virtual machines. Physical hosts are by physical hosts. Those typically stick around a bit more, and they have different pricing. That's available on our website for more details on that. We do not charge, it's worth noting, we don't charge per user. We don't charge per site. So if you want to take this aspect and then do a whole bunch of teams and have distributed teams working, that's perfectly fine. You're not going to get charged per team or per user. Other questions? I realize we're right at the top of the hour, and I'm not going to try and drive into more slides or let things go. We've been trying to go as we go. One of the things I would encourage people to do is this is software that's available. So we really encourage people to download and try the software. I have the link is here. Install it, play with it. You just need to spin up a cloud machine. This isn't SaaS, so you're not giving us your credentials or cloud information. You're literally installing the software, doing everything on your own system here, whether it's on premises or in the cloud. And that's really what we like to encourage people to do. And then join us in our communities and collaborate with us, because we want to hear about what you're doing. That's how we improve. It's how we extend the system. We're very driven by customer feedback here, and we love to add new capabilities where people can get excited about how we scale infrastructure as code. With that, Cody, I think I've gone through all of the material that I'm gonna need to take a break and drink a big glass of water.
Well, Rob, I'll take it from here. Thank you so much for taking the time to join us today and for splitting your demo up into 4 or 5 demos to really illustrate all your points. So thank you so much for all the work that went into this.
Thanks. Appreciate it. Thank you.
Of course. A reminder to our audience today that the session was recorded. So if you'd like to rewatch this, the on-demand version will be made available shortly after we conclude. You'll also receive an email with a link to view the replay. It will also be viewable on the devops.com website at devops.com/webinars. So we do have 4 $25 Amazon gift cards to give away. Our first winner is Ethan B. Our second winner is Samit N. Our third winner is Antoine A. And our fourth winner is Emily W. So congratulations. Keep an eye on your inbox to claim that gift card. If you don't see that email, just check your spam folder. So we would also like to extend our gratitude to Rackin for sponsoring today's webinar. And my final thanks, as always, goes to you, our attendees. We really appreciate you taking your time to be with us today, for spending your time with TechStrong. Please fill out our post-webinar survey, and we hope to see you at a future TechStrong Learning event. Have a great rest of your day, everyone.